Hello friends, I welcome you to EPG Pathshala. My name is Dr. Amit Katoch and I am working as Assistant Professor in University Institute of Hotel and Tourism Management of Punjab University. Dear students, I would be taking your module on Airport and Terminal Planning under the paper Aviation Industry, Ticketing and Frontier Formalities. After going through this module, you will be able to learn about terminal planning and design process of an airport, know about forecasting, learn about terminal capacity, demand analysis and LOS, learn about the computer simulations, about baggage handling systems, study the security planning at the terminals, learn about airport facilities, and it will also educate the learners about automated people movers and passenger boarding bridges. Airports are important natural resources and play a significant role in mode of transportation. They help not only in the transport of passengers but also in the carriage of goods at destination, regional, national and international level. An airport may be described as a facility or an aerodrome which provides spaces for flights or aircraft for takeoff or land. It also provides other amenities or facilities such as control towers for air traffic control, to adhere to compulsory and advisory messages to aircraft from the ground, hangars which are enclosures of aircrafts, and terminals which are building in airport which facilitate embarkation, disembarkation of passengers, purchase of tickets, transfer of luggage and security services, apart from presence of passenger facilities such as restaurants, shopping facilities, etc. and facilities for immigration such as customs and passport or border controls. Airports which are large in size may also have other infrastructural facilities such as taxiway bridges, which are bridges over motorways, waterways and railways which come in the way of runway. Airport aprons, which are spaces of aircraft which is used for parking, loading or unloading luggage or goods, refueling or boarding purposes. Fixed base operator services such as the organization which provides services or facilities such as parking or tie down, refueling, hangering, flight instruction, flight maintenance or related services, and also emergency services. Overall, the airport is divided into airside and landside areas. The former includes the spaces or areas accessible to aircrafts which are runways, aprons, ramps and taxiways, whereas the later includes areas available for passengers or travelers such as check-in and check-out, parking lots of traveler vehicles, public transport, that is public transit or mass transit which is shared passenger transport service, railway stations or roads for accessibility. In order to proceed to airside areas from land side, it requires checks whether security or passport controls for passengers as well as the staff present on the airport. The airport and terminal planning is a vital aspect in airport as it helps in developing passenger airport terminals as well as in analyzing the key issues related to airside and landside components of an airport. The airport planners and designers are continuously struggling to design airport and passenger terminals to provide efficient and swift services to the various stakeholders which are present on the airport or who come to take the service, such as passengers, whether it is a small airport or it may be a large airport. Also, the areas in airport and passenger terminals should be able to provide standards of ICAO, that is the International Civil Aviation Organization, and be updated with the latest technology materials. There is continuous shift in technology, structure of the industry and operations of the airline. Hence, planning is required for security screening, electronic check-in or check-out, low-cost airlines, concessions, cost effectiveness or consolidation. But planning aspects do not include only the above mentioned aspects, but other matters which are continually coming up due to air operations. In the earlier times, the airports had limited operations, but in the present times, when air travel has greatly multiplied with larger aircraft jets, better competence and flexibility are also required to accommodate higher number of passengers and baggage. Eros Saarinen in 1960 played an important role to design the airports. In 1961, he designed TWA terminal at New York City, John F. Kennedy International Airport, and in 1962, he designed the second terminal design at Dulles International Airport, that is IAD. But surely these terminals had been designed not keeping in mind the guidelines, however they acted as symbols for further growth. And clearly it necessitated more systematic and proper planning for airport and terminal plannings for the future generations. Now I will discuss about terminal planning and design process of an airport. Airport terminal planning of an airport is a very specialized work and involves a lot of aspects which are to be analyzed properly. These includes a lot of aspects such as environmental aspects, commercial aspects, operational procedures, safety, security, financial aspects, maintenance related, engineering linked and others. The planning phase broadly involves two aspects. Firstly, the getting together and cataloging of facts, information and parameters that will help in planning and design of the amenities at the terminals, and secondly, in determining forthcoming predictions of the airport traffic depending on passenger flow, cargo drift and airliner schedules. And when all these two aspects have been worked out, the terminal planning starts. Based on the information, the concepts are redefined progressively into richer concepts by evaluating them. And lastly, all these refined concepts become the basis of the preliminary architectural and engineering plan design, project development, specifications and cost approximation. Terminal planning and design process involves outlining the terminal facilities, which is followed by the design project process. The airport provides an array of services to its users, such as airline passengers, persons who come to take or leave the passengers, companies who are engaged in tourism industry, airport administration, government bodies and air aviation regulatory bodies. Hence, the facilities should be developed to satisfy the need of each user and to be constructed according to strict guidelines including SAPs, which are standards and recommended practices. The terminal compound or complex comprises of the interface amongst aircraft, travelers and the several modes of landside conveyance. The terminal system is made up of interrelated subsystems which primarily include landside, that is non-secure, passenger processes, that is departure concourses, arrival concourses, concession spaces before and after immigration clearances, airside secure departure concourses, that is pre-boarding lounges, in-transit lounges, concessions which include souvenir gift shops, especially F&B, duty-free shops and services related to spa, entertainment, business centers, forex, checked baggage handling areas that involve baggage loading and unloading areas and government check areas which include passenger and baggage screening areas and checked baggage screening areas. Hence, broadly the terminal complex encompasses three principal mechanisms, that is airside, terminal and land side. The airside terminal facilities include aircraft parking facilities, gate aprons, aircraft maneuvering facilities, taxiways, ground service equipments, aircraft servicing, service and emergency response, blast fences, waste disposal, refueling facilities and winter procedures. The terminal building facilities are also important and constructed keeping in mind the key functional factors such as operational factors and business aspects that affect airport operators and the local community. Also, their design and plan is made keeping in mind the demand pattern and needs of the travelers, airlines and their aircrafts. Also, their design has a flexibility part so that they could be further modified in case the demand and supply patterns vary. These operational, functional and business related drivers includes security planning, passenger and baggage management systems, IT based technologies, sustainability aspects and involving green technology, demand based management concepts, shopping facilities, eating facilities being others. In other words, the basic aspect of the terminal building component of the terminal complex includes programmatic parameters such as LOS, that is level of service standards, that define the desired performance for different terminal components and demand basis. Terminal facility requirements includes check-in ticketing, passenger screening, concessions, hold rooms, circulation, baggage claim, airline offices and operation areas, baggage screening system, baggage handling, support areas, building systems, international facilities and other facilities. Functional relationships, flow sequences, that is employees, passengers, visitors, baggage, deliveries and waste removal. Terminal concept development, which includes national and international terminals, configuration of concourse terminals which may be centralized or decentralized, single or multiple, equipments used in terminals and swing gates, and movement of passengers, mover systems of passenger and taxiway finding and signage. The land side terminal facilities provide interface linking airport with local area transportation system. The broad facilities include pedestrian facilities, motor vehicle lanes, entry or exit roadways, transit staging areas, parking and rail transits. The terminal facility planning is followed by design project process which comprises the type of projects, type of services, and identifying a preferred terminal facility solution. The types of projects are determined by the size or extent of the airports, which can be small, medium, or large. Further, the terminal planning and design project may be new, result of expansion or renovation. This design process involves setting project parameters based on a gathered inventory, designing the facility according to forecasts available, constructing conceptual alternatives, evaluating them, and selecting an appropriate option. The type of services comprises the most excellent course of action through technological analysis and qualitative way of thinking. These services can be grouped into four main categories, that are facilities, programming, planning, design, and specialized technical analysis. Identifying an ideal terminal project comprises following a typical project approach, which depends on whether it is new or result of expansion or renovation. It further also depends on the type of stakeholders' perspective, airlines, concessionaries, and airport management. For terminal planning, it is important to set goals and objectives and traffic forecasts. The programming of terminal facilities or services involves different methods. In order to use programs for master plan, conceptual plan, schematic diagram, and renovations, we require different types of details, inputs, and should be able to justify the need of the user. After the goals and objectives are set, conceptual planning occurs, which involves clearer focus based on the engagement of the stakeholders and reviewing developing concepts. After all reasonable options have been developed, an evaluation of them is done to yield or adopt a concept which is advantageous. But the following areas should be taken care of, such as land side, terminal, sustainability issues, flexibility, local community issues, environmental issues being others. Moreover, the evaluation criteria may also be grouped into air side, land side, terminal cost, site, etc., and scoring given +1, 0, and -1. Idealistically, the yield of the subsequent evaluation is known as recommended terminal development concept. Again, the shortlisted options are again reviewed, known as concept refinement, to further refine the terminal concept. Further, it involves concessional planning, conceptual phasing, program criteria being others. It is followed by the design process, which involves schematic design, design development, and contract documents. Further, it involves value engineering, and that will result in minimization of capital and operating costs. Further, the processes involve program management, construction management, and project delivery options. The project delivery options may involve four means: design, bid, build, design, build, construction management at risk, and BOT, that is build, operate, and transfer. Construction regulations and building codes are the principles or values to look after the public health and safety. Also, a certificate of occupancy gives lawful documentation and the building is safe and in a livable condition. Now I will discuss about forecasting. Forecasting involves predictions based on aviation operations in the future. It involves analytical analysis of the previous and present airport trends air traffic prospects, and any other factor which may control local aviation market. Some of the various aspects which a planner should consider prior to airport development are demographics, socio-economic data, disposable income level, aviation factors, geographical factors, and other factors or attributes which may affect the overall planning process, such as taxes, fuel costs, local community attitude, political developments, currency constraints being others. Long-term forecast of airport can be done through share analysis of the airport in the regional traffic, trend analysis, or through forecast of socio-economic status through regression analysis and econometric modeling. There can be a large number of sources for the forecasting, such as survey of passengers, survey of airlines, airline data, flight schedules, airport records, peak hour data, or other sources. Now I will discuss about terminal capacity, demand analysis, and LOS. Once the terminal project aspects have been understood, the terminal planner and operator needs to see that all the elements or components of the project are properly balanced or not, or whether they complement each other. If we increase or decrease the various components non-proportionately, it will just increase the cost and do not do justice with the structure. Hence, the basic components of airport terminal complex, that is the air side, the terminal building, and land side, should balance each other. And while designing them, various aspects such as seasonal variations in the air traffic and passenger flows both during peak and non-peak hours, routine and non-routine operations, and present and future needs are to be kept into consideration. LOS is a terminology commonly used by the airport planners and airport operators. It can be expanded as level of service and describes the service qualitatively and quantitatively, which is given to the passengers or travelers at various locations in the airport. The concept of LOS was primarily developed by Transport Canada in the 1970s because then the explanation of capacity was considered insufficient. TC defined LOS on the principles used in traffic engineering, and John Furin work which was used for the Port Authority of New York and Jersey. These methodologies have been used to create a 6-level scale which measures A to F from excellent level to system breakdown. Now I will discuss about computer simulation of terminal flows. The airport operations have become very complex, and with it are coming new issues and challenges. Some of the issues are related to quality of service, insufficient capacity, congestion of airport, financial planning, security issues, changing political and environmental situations being others. These issues have been neglected earlier, and some of them are of recent origin. So, all of these aspects have to be taken into consideration while conceptualization, planning, designing, and managing the airports. The increased air traffic has led to great increase in passenger flows at the airport terminals. The passengers want a smooth operation in an airport from entering the airport to getting the boarding pass, facing passengers, handling facilities, and vice versa. And so is the case with the airport developers and managers who want to give an efficient and good service to the customers, though insufficient arrangements or procedures may cause long queues, which may be a problem for all, and further lead to security issues, confusions, passenger missing, and delay of flights. Further, on account of it, the IATA may classify the airport to a lower grade due to passenger density and transfer times, and this may lead the major airlines to elude the air terminal. Hence, it's very important to effectively plan the air terminal or reconstruct the existing terminal depending upon the passenger flow in the current as well as future prospects. Though, apart from the architectural changes, the procedural changes can also ease the passengers, such as more security checkpoints can reduce the long queues. But all these aspects in terminal planning needs to be improved through modeling by predicting the passenger flows, simulation methods which can give good solutions such as passenger paths, emergency exits, and in knowing the bottlenecks. These methods predict the air traffic and passenger flows based on present scenarios and predictions which are based on the view of the experts. In order to develop simulations, the first step is conceptual framework and defining a worldview, that is the real world system's functional relationships which are perceived and described. The simulation basically involves discrete, that is state of system remains unchanged at discrete or event times, or continuous, that is state of system changes continuously. Discrete event simulations is used for an airport terminal as equations be derived to describe its characteristics and nature of operations. These are three types depending on the properties of simulations, such as event oriented, activity oriented and process oriented simulations. Objects or basic units inside the borders of a discrete system are called entities. Each unit has an various characteristic called attributes. They can be hybrid simulation systems to take benefits out of multiple simulation approaches. Whatever simulations which are used in an airport terminal can be modeled on the basis of two scales: macroscopic, that is on the basis of single integral system from ground side to air side, or microscopic based on individual facilities. Some of their examples are FAAs, that is Federal Aviation Administration Airport, Land Side Simulation Model, that is LSIM in USA, the Canadian Airport Planning Models, and SLAM. Now I will discuss about Terminal Operations Support Systems. Terminal Operations Support Systems involve flight information display systems, airport operational databases, that is AODB, resource and gate management systems, that is RMS/GMS, digital advertising and flight data, corporate communication solutions for airports. The FIDS supports an extensive array of display scenarios such as baggage gate and ticketing areas, MUFIDS, that is multiple user flight information display systems, touch screens, advertising and video walls and pages. It also automatically shows live flight status and weather updates, schedules, flight maps, rich site summary, that is RSS, news feeds and company video subscriptions and weather. FIDS implacably integrates with other applications or third-party airport IT solutions including public address systems, billing, baggage handling, resource management, gate docking, baggage reconciliation, website FIDS and navigation. Airport operational databases, that is AODB, aids as a central repository and translator for all crucial airport information systems. It streamlines and minimizes data entry, increase operational effectiveness and certify precise information by cross-referencing data between various systems. The system enhances complete proficiency and performance of operations by providing correct past and real-time airport information. It helps in decision-making progression by providing the latest functioning information to most terminals and permitting users, that is operators and passengers, to successfully accomplish their duties. Gate management system, that is GMS, or resource management system, that is RMS, upsurges aircraft parking efficiency, although it limits errors and costs. The adaptable GMS solution support custom gate necessities for individual single airports. Now I will discuss about baggage handling systems. The baggage handling systems, that is BHS, in the airport are responsible for transportation of the checked baggage from airplanes to baggage claim areas or from where the bags can be loaded to the aircrafts. It is a conveyor system present in the airports responsible for transportation of luggage from airline terminals to aircraft and vice versa. Nowadays, there are entirely unified, automated, computerized, high-speed airport baggage handling systems for all types of airports. It includes producing and assimilating systems for security screening, storage, sortation and transportation of departure baggage from check-in to departure gate, as well as transportation of transfer and arrival baggage. Now I will discuss about terminal security planning and facilitation. The security planning in the airport and terminals is of very important step as it protects the life of everyone present on the airport. So here the role of architects, planners, engineers become very important. A threat and vulnerability assessment of the airport is done strictly during planning of an airport as well as during the normal routine. Terminal security is not just restricted to anti-terrorism or hijack but also includes physical attack, theft, vehicle damage, vandalism being others. Terminal security focuses on all the three areas, that is land side, terminal and air side. Now I will discuss about the airport facilities. Airports are divided into air side, terminal and land side facilities. The air side facilities contains all areas available to aircraft and aircraft gates such as runways, taxiways and ramps. The terminal areas or facilities comprises the facilities for passengers and baggage processing systems. The land side facilities comprises airport road, parking areas, curb frontage, public transport, railway stations, ground transportation and check-in. Passage between land side and air side is tightly controlled at all airports. To access air side, one has to undergo security and passport control. Now I will discuss about automated people mover, that is APM, and passenger boarding bridges, which are known as PBB. The walking distances in the airport terminals should be kept as short as possible. For this purpose, proper mechanical or automated aids such as escalators, elevators, walkways and modernized APM are used. The automated people mover, that is APM or people mover, is a kind of grade separated, that is a junction of two or more surface transport axes at different heights and comprises a mixture of roads, footpaths, railways or runways. And these are mass transit systems such as Skybus, mini rail, etc. They may also provide taxi-like services. Then they are known as PRT, that is personal rail transits. And when they provide facility to 20 to 40 passengers, then they are known as GRT, that is group rapid transit. And when APM provides mass transits, they are known as MRT, that is mass rapid transits. For example, Hong Kong International Airport (APM) is a driverless people mover situated inside Hong Kong International Airport. PBB, that is Passenger Boarding Bridge, is a enclosed movable connector which outspreads from an airport terminal gate to the aircraft. It was invented by Frank de Yuen and also known as jet bridge, sky bridge, gangway, air bridge or aero bridge. Now I will summarize the whole module. Airports are important resources of the country. They play a crucial role throughout the world in air transportation of passengers as well as cargo. The airport terminal planning and design is an important step in developing the airport and involves a lot of planning. An airport complex can be broadly divided into three areas, that is airside, terminal and landside facilities, and their balanced development is very important to avoid financial losses as well as for the smooth and efficient functioning of an airport. Planners and designers plan all types of airports, whether big, medium or small. These airports are made keeping in mind the present needs and also seeing the future prospects of the demand through simulations. The aspects such as aviation factors, socio-economic data, demographics, geographical factors, local community attitude, political developments, fuel costs, taxes, currency constraints, all of these factors, these play an important role in planning. Long-term forecasting of airport, that is shear analysis of the airport in the air traffic, current trends are vital in airport and terminal planning. Also, the capacity planning in the airport terminal design is very imperative and consequently necessitates watchful and flawless analysis. The concept of LOS, that is level of service, as developed by John Firwan, is very important to explain the quality of service. This approach uses a 6-level scale, that is A to F, from the excellent level to system breakdown. The terminal operations support systems such as flight display systems (FIDS), airport operational databases such as AODB, resource and gate management systems, that is RMS/GMS, greatly aid the airport in the various airport operations. Also, the automated people mover, that is APM, and passenger boarding bridge, that is PBB, greatly aid the airline terminals in transportation from airside to landside facilities via the passenger terminal complex. At the end of the module, I would like to say that terminals have always been and probably always will be the bottlenecks of transportation, whether of ground, water or airways. Hence, the present need is to develop them as best as we can. Thank you and have a good day.